It's finally fall, and besides describing what old people do on a staircase and manifesting pumpkin spice lattes for white women, it also happens to be an incredible spectacle for those living in the northern hemisphere like myself around this time of year. Every year, millions of people flock to see the colors of the forest change from a luscious green to stunning hues of yellow, orange, and red. However, very few people actually take a close look at what's happening. Today, we're in the stunning Catskills Mountains of upstate New York, just a couple hours away from New York City. And honestly, I picked a pretty terrible day to go film this, but here I am, flying thousands of dollars of equipment in the rain. But anyways, today I'm here to answer some incredibly important questions that you've probably never even asked, such as, why do these leaves even change color before they fall? And more interestingly, after that, what happens to the estimated 40 trillion leaves that hit the ground every single year? With the help of our microscope, let's go find out. So first of all, not all trees change color, and if you've ever had a Christmas tree, I'm sure you know this.
Hoy simplemente vengo a decirte Feliz Navidad.
This is one of the primary differences between evergreen and deciduous trees. These evergreens often have needle-like, waxy leaves with a thick cuticle that helps protect them from the cold, dry winter, allowing them to retain water, kind of like baby oil.
Oh, for the kids.
While definitely suboptimal, these trees are able to perform photosynthesis, the process that plants use to turn light into energy, at extremely low temperatures and light levels. Even their iconic conical shape is intended to prevent snow from covering their leaves, and many even produce an antifreeze. This means that evergreen trees can grow year-round and in much harsher conditions, especially when compared to deciduous trees. Any tree that changes color is going to be deciduous. But this kind of begs the question, why aren't all trees evergreen? I mean, it would make sense, right? The more time you spend in the light, the more you can grow. Well, our first clue starts with the leaves themselves. These evergreen leaves are extremely strong and hardy, getting replaced only once every 2 to 5 years. On the other hand, we know that this quote-unquote normal leaf gets replaced every single year and is absolutely gigantic in comparison.
Guys, this orange is Gigantosaurus, whatever you say, Gigantosaurus.
This deciduous leaf probably has over 100 times the surface area compared to this evergreen needle, which helps it capture an incredible amount of light. And because they don't need to survive the crazy harsh winter, they're extremely thin, requiring significantly less energy for the trees to produce. This means that deciduous trees can grow far faster and more efficiently than evergreens. That is, when they're actually growing. Our second clue is where we actually find these trees. In incredibly cold and/or dry places, you'll notice that evergreen leaves in forests dominate the region. But the warmer the climate and more favorable the growing season, the more deciduous trees you're likely to see. In the Catskills, we can find both, meaning the strategies that both these types of trees employ to survive can work in this climate. The evergreens grow slow and steady year after year, while the deciduous trees grow rapidly every growing season from spring to fall, kind of like that old wives' tale. So why do the trees actually drop their leaves instead of just leaving them there and wait for the summer to return? It seems like getting rid of leaves just to grow them back would be kind of a waste, wouldn't it? And I know, you're probably thinking, well duh, the cold kills them. And yes, your intuition is right, but the cold is really only 20% of the issue. In fact, the leaves aren't actually murdered, more like reabsorbed in a process called leaf senescence. No need for the tree to waste all the nutrients in that leaf. To figure out the other 80% of why this happens, we'll need to look into the microscope. This is a cross-section of a pine needle that's stained. Much like us, plants have cells with similar structures and purposes to keep themselves alive, such as skin and blood vessels, except they don't eat McDonald's, get high cholesterol, and then die of heart attack. You can clearly see the epidermis, essentially the skin of the pine needle, which is the protective layer that helps keep out the cold and in the moisture. If you look carefully, you can even see the clear, waxy cuticle on the outside. Now, let's compare this to the epidermis of a normal leaf. This thin layer of cells is nowhere near as effective at protecting the internal energy-generating palisade cells, but because it's thinner, more light can come through, making it more efficient. Going back to middle school biology, besides eating chalk and violating dead frogs, you may remember learning about stomata. Just like humans, plants need to breathe, except they take in carbon dioxide and we take in oxygen. We have mouths and noses, they have stomata. These tiny openings fill the leaf with air and allow gas exchange to happen. But they also let out moisture, which is bad when the water around the tree is all frozen and inaccessible. Known as transpiration, water inside the leaves evaporates when the stomata opens to let in gas, which you may notice as fog rising from a forest, especially in the morning. When trees lose their leaves, they don't have to worry about all that water loss. Not that trees worry about anything since they don't have brains, but it does help them survive the long winter. With the thicker cell walls and sunken stomata, evergreen trees have better insulated leaves and therefore lose less moisture at the expense of efficiency. The next important part to look at are the blood vessels of the leaf, or the xylem and the phloem. These are the transport channels for water, nutrients, and sugars like the glucose from photosynthesis. In the deciduous leaves, these are all concentrated in the veins of the leaf to avoid disrupting the large areas of the leaf dedicated to producing energy. These same areas that are extremely efficient in the summer would royally suck in the winter, potentially killing the tree if too much moisture is lost. In evergreens, these blood vessels run inside every needle, not just carrying nutrients, but also filling the leaf with antifreeze compounds that help it survive even in low temperatures. For deciduous trees, these nutrient highways are also the reason that leaves can even change color. All leaves actually have every chemical compound needed to be red, orange, or purple, but they're entirely overshadowed by the vibrant green of chlorophyll. This is the green pigment responsible for photosynthesis and energy production. Also, a common misconception is that trees turn yellow, then orange, and finally red. In actuality, they turn into a specific color based on the type or types of chlorophyll that they have. When the time comes, the tree breaks down this chlorophyll into nutrients like nitrogen, and the phloem carries these back into the branches, roots, and trunk of the tree to be used to regrow the leaves come spring. This leaves, pun intended, behind the vibrant orange, red, and purple carotenoids and anthocyanins that fall is famous for. These are the same chemicals that give carrots, cherries, and cabbages their vibrant hues, but also protects them from disease, herbivores, and damage from light itself. These may also protect the leaf from the cold, while the tree is finishing up sucking down and reabsorbing its own nutrients.
Suck.
This process of leaf senescence is an essential adaptation for many trees that helps them survive the harsh winter. After the tree has absorbed all the nutrients it can, it will form a special layer between the leaf and the stem, and the leaves will finally fall to the ground. When this is all said and done, the tree is fully ready for winter. Every year, countless billions of pounds of leaves fall to the ground in the United States alone. That's almost as much weight as your mom. As all dead things do, these leaves and their nutrients get recycled and join the food web. They act as a natural mulch and fertilizer for the near infinite number of microorganisms that live in the soil. Breaking down the cellulose and lignin, these colonies of fungi, bacteria, and larger organisms all rely on these dead leaves for survival. These tiny creatures then poop out nutrients like nitrogen, calcium, phosphorus, potassium, and magnesium back into the soil. And despite nitrogen making up 70% of all the air around us, without the bacteria in the soil, most plants would never be able to absorb this essential element. The resulting dark organic matter from this process is called humus. No, not hummus. Although, wouldn't that be great if this is where it came from? This humus is incredibly important for soil texture and structure, increasing its ability to hold both air and water, while also enhancing nutrient retention over time. Without leaves in the fall, many of these creatures would not be able to survive and support the incredible food web that all starts from the soil that we stand on. So go ahead and take that trip into the forest and do what humans do best: see color. It is an incredibly stunning sight that many of us overlook in our day-to-day grind. For some timing tips, I find that the peak colors usually only actually last for about 2 to 3 days before the leaves start to fall, even though most reports will say that they last for a couple weeks. This kind of makes sense, as trees want to drain the nutrients from their leaves as quickly as possible and then drop them as soon as their usefulness has expired. As the days get shorter and shorter, different trees will change color at different times, with those at higher elevation often experiencing cooler temperatures and changing color sooner. Just a half hour's drive north or south, combined with the change in elevation, can be the difference between trees that have completely changed their color and ones that haven't even started yet. This kind of shows us just how hypersensitive this adaptation is, and in my opinion, is one of the reasons why we should really take care of our environment. Most of us may only get the chance to see these peak colors a few dozen times in our lifetime, and as awesome as it is to stare at a screen for countless hours every day, I think the outdoors look better. Thank you so much for watching this episode of Not So Small. Let me know what I should investigate next. Enjoy the autumn while you still can. That was not a threat, by the way. Sounded better in my head. Have a good day.